as sir has already discussed, there are different ways of like systematic reviews. There are systematic reviews which I will show Prisma. There is another which is scoping review. Scoping review is usually done when you want to know about the scope of something. Like if you want to know like how many studies are done in, for example, disease, role of media in disease. Okay, so scope of this literature, how wide it is. So this is usually done by scoping review. Meta-analysis, sir has already discussed this in our last night, that meta-analysis is usually for comparison between different studies in general. Rapid reviews is, like sir was discussing, in the initial phase of virus, when you want to understand the reproductive number, you do it in a certain way. So rapid reviews are like when you want to know about it in a like quick way, like when there is something which is like if a pandemic is going on and there are certain set of papers which are in the initial phase, that for a quick review, this is a rapid review. It's again Prisma, but it has like adapted methods. And narrative reviews are usually what you do in your papers, like no formal reporting, like how you structure the papers and things like that.
So, hold on 1 second. So what is narrative review? Where do you use narrative review? Why, first of all? Do you guys use narrative review? Where do you use review for in your work in the past? Writing introduction, right? Say it again.
Finding research gap.
Research evidence gap, research gap, right? And that is narrative. There is no statistic. I mean, you might have statistics on certain things, but primarily the introduction is about narration. It's a narrative in the introduction, right? For that. But where do you do meta-analysis? Meta-analysis is used for what? Meta means multi, right? So you are using multiple studies to come out with an aggregated information on something, right? So for doing inputs of the parameters, I mean parameters of the model basically, okay? So that's where, so there are different reasons why do you do it. Again, what he's showing is people publish reviews only, nothing about modeling. They're just about a review on a certain topic, and these are the different. But typically in your modeling work, you do these portion of different types of review in different parts of your manuscript or different part of your research. Like inputs, you need meta-analysis. For introduction, you need narrative. You understand what I'm saying? So there is, behind the scene, you are using all these reviews indirectly. Although you are not doing it in a very systematic way. Word systematic is what he will talking about and describing, and therefore you have to know all these things before you go about doing it. Do you go over the Ryan also?
Yeah. How would you do it?
Yes.
Okay, so I was earlier discussing about the framework Prisma. So basically, as sir was discussing, so this problem was discussed by researchers, especially in medical field, that like different people are quoting different things. So why do we create a sort of systematic thing by which our conclusions are some evidence based? So I think it started back in 2009, and its recent version is 2020, as far as I know. So a group of 29 people, like 29 scientists and from various fields, decided to make a checklist in order to create a systematic review. Okay, so this is a checklist, and so this is a checklist of 29 items. I've included some of the things in this. So if you are performing a systematic review, so you have a time chart, a background of this, methodology, risk of bias, results, and these are different sections. Like you have to report this in a certain format. It's not like you can report it in any format that you like. Okay, so it's a checklist of like various things. Like these are the steps you need to follow if you are trying to do a systematic review search. Again, so there is a flow diagram which I'll show in the next slide. So there is a flow diagram which shows like how many studies or how many research papers were in a particular session. Like when you started, how many searches that you got, and then how you reduced them to in the next step, and then how you reached to the number of studies that you look at that you reviewed in the final stage. Okay, so again, Prisma doesn't tell you what to find, but it ensures that you clearly report how you find it. So there's no biasness in Prisma. Like it doesn't gives you like, oh, go to that conclusion. You know, it gives you methodology to reach a certain conclusion. This is a flow diagram of our paper which I published with Sir, and in the identification stage, we used Web of Science, and thankfully at that time Web of Science was free, and now it's only subscription based, or if your institution is buying it. So at that time it was free, and we started like the identification. There were like 1,122 papers, and then we did the screening, and we did the screening for title and abstract for 760, and then eligibility for 107 paper. We literally did 107 paper. Full in the full text eligibility, and last we included 56 papers. There are other sources which we find, which is called gray literature. Gray literature is like when you are finding information on some topic, there can be results which are like somebody has a thesis to submit. Usually these search engines like databases like PubMed don't have like that published report, or some government data, for example, like data from the meteorology department or in a journal. So these things you will not find in the PubMed or any other Web of Science you are using. If it is relevant to your study, we can include that as well in our thing. So it is called gray literature, and we identified 12 other papers from the gray literature which we used. So there are 4 steps which I have explained on the right side as well. First is the identification. Identification is done through databases. Then we have screening. Screening is like title and abstract. We like look at the title and the abstract based on our inclusion and exclusion criteria, but which we have predefined, which I will explain again. And then based on our title and abstract screening, we have an eligibility criteria like these text, like these papers we want to full read it, and then based on this, we want, like in the final slide, we want to like include, like these are the papers which we are including in our final studies. Anybody has any problem with these 4 categories, because these are very critical. 2 things which are very critical in as far as I understand in case of systematic review search is that your inclusion and exclusion criteria which should be very lucid, should be very clear. Do you understand? There should be no mixing between votes. It should be very clear to you like what study I am including and what basis. And these 4 steps, like how we have identified the studies, how the screening is done, what was the eligibility criteria again, like the background of which is, and what are the studies we included. And whenever you are doing a systematic review search, you have to give a flow diagram like this, and all the steps which you have followed, starting from the beginning to the publication to get it published.
Yeah, one more thing. So this diagram is not needed if you are quickly doing a short review for your getting an estimate of the parameter, or you are doing quick review for getting background information of your introduction, right, or evidence gap or research gap. There is no need to make this diagram. I mean, you can make it, but systematic review, as I was saying, it is done in a separate study. People don't do modeling and other things in that. It's only require reviewing papers of the literature on a certain topic, right? In that, you have to give, otherwise they will throw your paper right on from the desk. This diagram is so important to do that. It's called Prisma diagram, that is what he's referring to.
Good morning, sir. Good morning.
Okay. Okay, so there are 4 steps as you can see. Identification, screening, eligibility and inclusion. So I will go one by one how you can do it. So starting with identification. For identification you can use multiple scientific databases like PubMed, Medline, Scopus, Web of Science and Embase. Thankfully PubMed is still without subscription based, so you can use PubMed now, but all the others, as I've already told, at my time Web of Science was already like for free for all, but now it's not. All others are subscription based, so we can use PubMed. I will show the example with the help of PubMed. So then you use structured keywords for control vocabulary, and as I already told you, grey literature is also important depending upon your study. You don't want to miss some important study which are like not published in an article sense. Do you understand what I'm saying?
So what is the example of the grey?
For example, if there is some report published by, not in the paper, by meteorology department or in general public health department of the government, they don't usually put it in a research paper format. So that's grey literature. Or like somebody has written a thesis, you will not find it on PubMed, and it can be very relevant to your study. So this is grey literature which you also want to include. Okay, so remove duplicates, I'll show. Okay, so now the important thing is the way we started. I'm coming back to that thing. How we can search, like what keywords do we use, right? So there is a methodology to that as well. So it's called PICO or PICO. So P stands for like what we are studying. Like if you are doing research in animals, so P stands for population of animals. Like what is the individuals what you are studying? Do you understand? So secondly, it's the exposure. So what's the risk factor? How is comparator? Like what you are comparing here, and fourth is outcome. What you want to study here. I can show you with the example of human infectious disease maybe in the next slide. What is PICO? So starting with like contact structure. If you remember, our question was like human contact networks, right? So what can be a keyword in contact structures, right? So keywords can be in contact structures can be like this. For example, contact networks. That's a keyword. That when you want to know the contact structure, like if you remember in the initial slides, I show you that this is what we are trying to find here. What is the role of human contact networks in the spread of infectious disease in a general sense? So contact networks. What can be the contact key? Similar keywords to contact networks can be like social networks, contact patterns, temporal networks. These are things you can use as a keyword. Okay. Again, what is our outcome? What are we trying to study? Is infectious disease transmission. This is a keyword. Infectious disease transmission. Disease spread. Right? This is another keyword. Outbreak dynamics. This is another keyword. And the important thing, population. What we are studying here is humans. Like, or some people has included in the title as people or individuals. Now, before coming to query, depending upon which database, scientific database you are using, there are different ways to search and find it. Like, there's an important term which last lecture I was also discussing, it's called MESH, M-E-S-H. So, I will show on the database PubMed what MESH actually means. So, usually it's like, I explained to you this again because this is very important. These are four things, PECO, as I already told you. So, you can combine these four, like in this case we have three, but you can combine these with like contact structure or social network or contact pattern or temporal network. These are all similar things. Do you understand what I am saying? So we can combine these in the query with or. Like whether paper has mentioned this or this or this or this. I want all these studies. Are you getting what I am trying to say here? Another thing like infectious disease transmission. You want contact structure and infectious disease transmission, both in the paper, in the title or abstract, right? Because that's what we are studying. And population should be humans, like it can be in animals. We don't want to study at that point, because like what we are trying to search, right? So these three can be combined with and, like the general logic here which you are already aware of. So we can combine these with or, like contact structure, disease context and population with and in between, like infectious disease transmission or disease spread or outbreak dynamics and humans or people or individuals. Do you understand what I am getting? So I will show you like one example. So for example, I have already opened this. This is a PubMed. Okay. So let's start a fresh thing. In the morning, just to see if it's working. Okay, so I've already discussed what keywords we can use, right? You can search for other keywords as well from different sources. Like AI can help you in searching keywords. Give other keywords which are relevant. Okay, so here is the query box. It's called advanced search builder. In Web of Science is also called advanced search. All the other scientific databases have this advanced search as well. So here it's a like what you want to find. Like how you find author, all fields. They are very like editor, filters. They are very mesh terms as was sir was discussing. So I will explain with an example what exactly is a mesh term here. PubMed used mesh terms in Web of Science. When I used it, there was no term was like mesh term. They didn't like mesh term is something which a scientific database has already included. Like infectious disease transmission is a mesh term. So if there will be a word which is similar to it, like disease transmission, it will also give like when you include infectious disease transmission, mesh term also gives disease spread, disease transmission. Do you understand? So the similar words are in a mesh term. So it usually gives like this. So and this depending on like here, like this is very important, like title abstract. We want that word in the title or abstract to give strategies which are more relevant to our search. So for example, in our case, these are the different like as I explained you. Like so how you will do it, you will put it here, for example, mesh term. Mesh term is our here. Infectious.
You can actually have your computer out and do it along with what he's doing. It will help you actually.
See, this is exactly what a mesh term is. So infectious disease transmission, like every word cannot be like every term which you are putting cannot be a mesh term. Mesh term is something which is specifically already devised by a scientific database, right? So this is like infectious disease transmission is a mesh term which is already found here. So when you put infectious disease transmission here, it means it will also include studies which are disease transmission or infectious transmission, or you know, like the similar terms are already devised here. Do you understand what I am getting? Okay. So for the transmission, it's and then here is a add. As I've already told you, you want to add it with and or. So in our terms, we want to add it with or. Sorry, and. What we are studying here, humans, right? So we can see HUMA and is human a mesh term here? No, humans is not a mesh term. What about humans? Humans is a mesh term. Do you understand what I am saying here? So humans will also include people, individuals, etc., etc. Right? This is way to refine your search.
Yeah, 1 minute. Where is this? Were you guys able to find the page he's on right now? Yeah, everyone knows it?
You can type my advanced search and you get it.
Advanced.
Yeah. Sorry. So again, now we should. Oh no, I did it myself. So now when I write here humans, should I combine this with and or? Should I combine this with and or? What should we choose? And because as I earlier discussed, we should combine it with and. The reason is, if I go back to my slide, yeah, here PECO, the keywords, contact structure. So we have one from the outcome, which is disease, like infectious disease transmission. The other one, population, humans. So we should combine this with and. Do you understand what I am trying to say here? Right? And then we want to have another key structure for contact structure, right? So it's not necessarily always that you use the mesh term all the time. You can use general, like from here, you can use title abstract, whether it's in title or abstract, like contact structure, for example. Contact mixing, your contact in general. You can use any term, you know, and we combine with and, right? And now if you want to like give similar keywords with contact, so maybe mixing, and we join it with and or. We should choose and or here. Or. Right? So this is the query box. Now there is no definite way that this is the keyword structure that you use. You know, depending upon your particular studies and like you have to spend some time understanding this like keyboard structure, like because it will give you search results, different search results depending on different keyboard structures, right? And you have to spend some time analyzing these kind of results, like how many papers it is giving. Papers are based on like which fields. Like if I search this one, for example, this is a query box, right? These are the query box which I did 2 days back or 1 day back. So if you search on it, so here we get 39,197 results. So these one papers are with this query box. Like you can change it, like if you want to do a recent, like what recently papers are published. So there is a 1 year, 5 year, right? And what you want to see here, like abstract is available on this site, or then you can choose the article type. When you meta-analysis, review, systematic review. If you are doing a systematic review, you should actually avoid taking systematic review, another systematic review, and like influencing your review. Do you understand what I am doing? Am I making sense?
Yes.
Right? So these are additional filters as well. Like you can explore by yourself, like species, sex, like lot of things. You know, like if it's this is specific to like clinical study, like clinical study done on humans. You know, there will be lot of papers which are here based on these query terms, which are clinical trials, right?
It could be even for the modeling work because you have gender
Yes.
in the HIV, for example.
Yeah.
So gender is used, even age group in the vaccination for models for vaccination, you need age group. So there are very specific the studies you can find through that.
Again, there are other like preprints. Preprints, like I think you should be aware with this. Like when you send paper to a publication, you put it in a preprint in, for example, I'm sorry, I'm missing the word. Archive, bioarchive or archival journal. So preprint are not peer reviewed, right? So it gives you option whether you want to include non-peer reviewed studies in your search query or not, right? So this is the way. Again, since I have put it in a very loosely term, you can again play with this. This is a like very good way to play with different keywords and find different kind of results based on it, right? Like if I go back and show you what, like after doing like lot of searches again and again, this one, okay. This is
So these numbers of the results that are coming, is it there in the flowchart?
yeah, it is always in the flowchart. Yeah. So sorry, I forgot to mention. Yeah, these numbers which are coming here, these are like you need to document them all in the flowchart. You have to show that this is the number of like studies in my ancient search, right? And then I will explain you like how to extract it. Like suppose based on your search, you get a certain number, and then this is the way to extract the papers from this. It will not give you the whole document, but it will give you if you are using Web of Science, it also gives you options like whether you want to take the title only, whether you want to take the abstract only, and other things. But in general, if you can use it and like you can abstract, like there are different ways to abstract depending upon your taste. So like I use the citation manager because I will use the RAN software. RAN software is a very wonderful software. Like if you are reviewing, like if 3-4 reviewers are reviewing, there is a like software on which you can show, like which it can show you transparency. Like you can see it in a better way. So all results which are related to it, create file. So it will give you an MBIB file which is there. So this is the file. Okay. So our first step, again I will come to the my slides. This is the conclusion of our first lab. I have done only on SignWeb. You can use other sources as well, right, to get the papers. And from 2 or 3 sources, then we will aggregate and see like how many papers are there. And different sources can give the similar paper. So we don't want to take similar paper from different sources, right? So then there are software like Zoitro. I can show you. This is another software. here you can put papers from different sources, and it will show you like which are repeated papers, right? And Ryan can also show that. I think Ryan has also a big feature in it. So this is the completion of our first step. We have identified the database and extracted the paper from it. Now next step, we want to do the screening, right? Screening will be based on our eligibility criteria. So we have to define the eligibility criteria. So mesh, I already explained to you. Like some scientific databases have specific terms which are called mesh terms, which can help us to give better papers because the single coding papers are included in that general term. Okay. So this is the same thing which we do. Like save and export the results. At every point you need to like clearly take your query. Like this query, even like what we have done it. Sorry. Yeah. So if you are publishing this thing, you have to mention the query itself in the paper, that this was our search query, these were our keywords. Do you understand what I'm saying? So it is transparency. Like every step you do, it's nothing hidden from anybody. Okay, so next step will be, this is what we have saved. Like we can put citation manager, it gives usually in NB format. In Web of Science, because I use Web of Science, it gives you in CSV files. Like in CSV files, you get the title, abstract, publication, whatever you want to include. Like it gives you various options based on that. You can do the screening manually as well. Like if the number of papers are less, you can manually see at the title and the abstract if you have like time to do it. Right? If there are 700 papers, you define an inclusion and exclusion criteria and look at the title. Like whether this is quoted by our study. If you are in doubt, look at the abstract. If you are still in doubt, maybe later. Keep that paper for maybe later. Like maybe later I will come to see whether I want to keep this paper for full text assessment. Full text assessment means like you read the paper fully, right? At least more than the abstract and the title itself. Okay. So again, this thing is very, very important. As I'm saying from the first slide, the sort of things which you need to the publisher for a systematic review or the Prisma diagram which I have shown before, the query, Prisma diagrams include this, like, again I will go to the Prisma diagram because I want to explain you this thing. Like these are the like 1132, like in our search query it's like 40,000 something like that. Do you understand? We need to refine it. But this is the first step. You need to show that this is the number of studies which we get. Right? And if you are excluding, like we want to do in 5 years, and if you want to exclude, like Web of Science has also different options, like if you don't want to go to the study, because these results will be from various fields, the archaeology, even in general, right? If you don't want to do, like if you don't want to include paper from that field, because you think that that's not relevant to your study, so you have to mention properly that in this step, I have excluded papers from this study due to this reason. Do you understand? So this is exactly how it works. So this is inclusion exclusion criteria. For example, in our question which I'm discussing from the start. So the inclusion criteria should be like we are talking about human populations here. Studies which are analyzing contact networks, contact patterns, social mixing, or contact matrices. This is what we want to study about, right? Then relevant to infectious disease, like this can be, the contact networks can be in general for any other subject related field as well, but we are specific to infectious disease modeling. So we want papers which are relevant to infectious disease or transmission modeling inputs. Again, for our inclusion criteria, we have included papers which are original research, like published papers, right? Not peer reviewed papers. Not peer reviewed papers, I'm sorry. Any relevant setting, like whether it's done, the study is done in a school or community or workplace or population level in general, right? Exclusion criteria, like as I was already discussing with you, we don't want to include studies which are based on animals, right? Articles which are discussing the spread of disease in animals, like contacts of animals. Do you understand? So we don't want to introduce that. When there is no human contact structure analyzed, we don't want it. Network, we want to explain what exactly network means. We don't want to, like this inclusion and exclusion criteria is depending on what you want, right? I'm just showing you by an example that in this case we can choose this. There is no like defined criteria that this should be inclusion criteria and this should be an exclusion criteria. It depends upon what your inclusion and exclusion criteria is, based upon what you are trying to find. Am I making sense? Okay, so I will proceed further. Now, the screening. The screening, as I already told you, it can be done manually as well, but there is beautiful software called Rhyme. I will show it Rhyme. So you can make an account. It's free of cost till now. Okay. So this is now. Okay. So I will show that example which we downloaded just now. So it's RAYYAN. You can download it. You can make an account in it, and then you can start using it. So okay. So here, this is how you can add new review to it. So create new review. So we are doing a new review. Here you can add the title in the initial case, whatever title you are putting here. Right? So for example, this is our title. What is your review tab? You are doing a systematic review or a literature review, it helps in general literature review as well. What is your domain? Do you want to specify some domain or you don't want to specify what is your domain? That's also there. And if you want to upload from different databases like from PubMed, from Web of Science, all these things. As I've told you, there will be duplicates. Like the different databases will be giving similar papers. It can help you to remove, detect the duplicates and remove them as well. When you upload different files from the different search bases, right? Then this is review data. Here you can give. It is an AI-based app, so it gives you keywords which you can include or exclude. I will not go into that. Here is the thing which is the second step, which is screening, right? So it gives you option for the screening. I will take that. So this is first study which we have extracted just now from our keywords. So it gives social contact patterns relevant for infectious disease transmission in Cambodia, right? I didn't mention in the first slide that where do you want to conduct a study. If you want to conduct a study, you can add a keyword in the initial slide, India. Okay? So it will give you studies relevant to India. But since we have didn't do it, so it gives you studies around the world. Right? So now here you can see the abstract, right? You can read the abstract. You can see the timeline. We can define the timeline earlier as well, or at this moment as well, when this study was conducted, and based on your inclusion exclusion criteria, you want to include this study, you want to discard it, or you want to keep it for later, like you want to see it again, right? So if you click include, it will be included, like I have included this study, right? Do you understand what? So it makes like, if I open this, like income inequality linked to infectious disease prevalence. If you know the title from my first slide, I think this is the study which we don't want to include in our search result, right? Because we want to see how mixing of human individuals help in disease spread, like infectious disease spread, right? This is about something related to income inequality. We don't want this in our selected paper, so we can discard it by like this, using this, right? So this is the software which helps you to like include, exclude, and once you are done with all this, the selected papers, you can go to full text training of these, right? So I haven't finished this thing, so this will not show the next step. But let's go on my slide again. So this is the screening process which I was showing you. So we exclude studies which are irrelevant to our such criteria. We want to apply our criteria consistently. Process is reviewing titles and abstract as I have shown you in the software. Classify as include, exclude, or maybe we see it later, right? As like tick for include, cross for exclude, and objection mark for whether we want to see it, give it a look again, right? Implementation is like screening performing manually by reviewers. As I've told you, you can invite your reviewers on this and they can independently do it. And it shows like this is done by this, like this paper is selected by this reviewer or that reviewer. Do you understand? And as I've shown you, like it is quoted by Ryan, and you can use maybe when you are unclear about it. Like if you read the title and abstract and you are unclear whether you want to include this or exclude it, this you can put it in. So at the end of the screening process, you are at a full text assessment. Like if I show from the previous slides, so this is the database which you get at the first step. You have done the title and abstract screening, and you read here like eligibility, like papers which you want to read for full text review. Do you understand? So from a large number of papers, you are reducing it to a small number of papers which you want to read full text for your research problem. Do you understand? So, okay, this is very important for like excluding or including a paper based on what you are trying to search. Like, what does this model inform? Okay, what I can extract from this paper. Do you understand? This is what should be post-process. Like, what should be going through your mind while selecting or disregarding a study. These are the questions that you should typically ask yourself. Like, why should I include this or why should I exclude this? Does it support or challenge my assumption? Like, whatever your assumptions are initially, does it support it or challenge it? Can it help? Like, whatever you are trying to find. Like, in your case, we are to find social contact pattern in human transmission, right? So, does it support that thing? I have shown a study which is irrelevant to it. So, if it doesn't support our study, our objective, you should discard it, right? And is it relevant enough? If it's not relevant enough, maybe for a full text, so you put it in a maybe criteria. So these are the things which should go in the backdrop of your mind while selecting or discarding a particular study. And that is the next step, like fewer number of studies which you want to see the full text assessment. So the purpose should be confirmed whether screening studies meet inclusion criteria. Sometimes what happens is that title and abstract, from the title and abstract you think this study is relevant to our query, our objective. But when you look at the full text, you understand the methodology or the process is different from what you want to it. You know, like the title and abstract shows the promising, but the full text assessment shows that no, this is something which he has done is not related to what we are searching for. Do you understand? And it happens very often. In full text assessment, it happens. Like in my case also, if I can show you from the previous slide, we have 107 plus 51, 107 studies which we did full text assessment, but 51 of those were not meeting our criteria, like what we want to extract from that paper. So this is implementation and outcome. Like this is again, we want to apply criteria rigorously. We want to reason. Again, I'm telling you, you need to document everything, why we have excluded something or included something. Because as we submitted paper with Anand sir, the reviewers asked us the exact number of papers from the starting point and why we excluded some papers and what were the key terms. Like as I told you, like which studies which didn't include it, every detail. Like there was a, if I will show you my paper, there is full page of like key terms which we exclude. Do you understand? Like around 30 pages of everything. Why we exclude this? Why we include this? So you need to be very transparent in this, and you need to document every step. So outcome is like we get a final set of studies which are inclusion for your inclusion, and based on these studies you can determine the answer to your search query. Like that for in our case, the search query you can. So yeah, this is the same thing. Yeah, so you can do like meta-analysis after this as well. Yeah, answer the search questions systematically. I think combine evidence from individual studies. Yeah, this is something which is done after a full text assessment. So what we have learned today is from searching in journal to searching evidence-based searching, which Sir was also focusing. So these are some of the software which we can use. I have shown you some so far. The identification purpose as from the Prisma four major things. The identification for identification we can use PubMed, Wetlands, Scopus, Web Science, and this is like keywords. They are like depending on which one you are using. There are different keywords and vocabulary such like some are mesh terms, some you have. For difference, like if you want to remove the duplicates, there is right row and node. Mental, I think mental is something which is very popular if you are writing in text format. People use. And for screening, there is RIAM, and there are other as well like competence. I haven't used it, but yeah, these are another for screening purpose. Like it does similar to the RIAM software. Okay. Yeah, that's all about the systematic review search from my side.
Yeah. Thank you. Yogesh, I think we also want to see, and maybe when we come back later in the day, your papers so that you can see exactly what the outcome look like when you are done with this literature review, and how do you present it for the reviewer. That is very important. Another thing I want to point out, the reason he showed you the RIAM software, because it's a free, of course, at least the initial version. So you can use it for trial and error. And these tools, you don't, if you have not used it, these tools tremendously help your review process and speed up the process drastically. And initially you will find it little like, you have to adjust to these new softwares, the way it is supposed to run, and so on and so forth. But once you do it one or two study, it will become obvious, and you will see how fast you do the review for your introduction. Google Scholar is nothing as compared to what these software can do. There is reason why people have spent so much time in developing these softwares. And also on the databases, there are coding in the databases also, like and, or. He has only showed you few things, but if you drop down menu, you were seeing there are thousands of other things that you can use it. And we are not really use it that much, so we are hardly able to, think about this. In today's world, if you do not know how to use chatbots, AI-based chatbots, you are illiterate, literally illiterate. It's so important right now. Now, that doesn't mean that you have to intelligently use it, right? You can't just use it as a black box, copy and paste. That's not what you can do. Dr. Anamika will be talking about this thing later on. But this is where it's very important you do review every day. If you are involved in the research, you do review every day. And these things drastically speed up the process. And that is what, and I think I've asked him to show his paper that is already published. He's a very good researcher, and he has published many papers. But this paper in particularly is on literature review. And it took like, how many months it took for us to complete?
In the initial phase, it took like 9 months.
9 months. Yeah, so 9 months for just completing the work of, and it is just reviewing the literature. Think about that. We think we are reviewing the literature and we get information in 1 hour or 2 hours. That's not possible. It took him 9 months. So there's lots of things you can do in this. The goal of this course is to expose you. There are things we cannot. Think about each one of these topics that we are covering here in this course is meant for a whole semester long course. But we are trying to expose you so that, if you don't know, then what you will look for. If you know, at least you can look for it and get the information from other sources also. But exposing to the software is the need of the day, need of the time right now. So you need to know all these softwares. Okay.
This is one intro to internet is not working.
Maybe we can do it later on actually.
So I'll finish just by telling you a little bit about my recent work. So this is the first paper which Anusar is already discussing. It's in the Journal of Math Bio, which is a very good journal in Math Bio. My PhD research is basically understanding the phenomenon of T-cell activation. We are looking like in the ancient phase, like how T-cell decides like whether we should attack an antigen or not, and we are looking into various aspects of things. This is a protein structure, and one of paper is like we did comparative evaluation of the very paper, because like in the literature, as you sir was telling, with the meta-analysis we can see whether the parameter values, what different parameters values are taken. So there was a lot of papers which are published on mathematical aspect of like phenotypic papers which discuss T cell activation, and they have taken different parametric values. So what I did is I take all the papers which are published in that lens and took all the parameters values which they are taking, and then based on what actually experimental results are. So I evaluate the mathematical paper with an experimental result. Like this mathematical paper can reproduce this experimental result or not. So this was my first paper, and it's already published now in scientific reports. There's another paper which is on mechanochemistry. So it's a completely different field, like changing of energy landscape with the structure. Like with the structure, the energy landscape also changes, and it is in review right now in Royal Society of Open Science, which is in peer review. So I'm sidewise working on, which I was discussing last time as well. I was working sidewise on human behavior change influencing COVID-19 dynamics, and we have luckily got data from Germany. It's called Cosmo data, and with the help of this, we are trying to, like, we have different mathematical models, different set of mathematical models, and trying to predict like which fits the data well. Right. So this is all about me, and this is the final message. Again, he is called the final. He's called the father of modern evidence-based medicine. So if you know, like when a medicine is prescribed, you do clinical trials, right? And one clinical trial shows that on this population, this medicine worked well. Then another clinical research shows this medicine on this population worked well. So this was the guy, he was earlier critical of this thing. He said like different people are doing research, clinical trials on different population set. Why don't we use it in a systematic way? Like why don't we use a guidance criteria which will like influence all the things, right? So although he was not part of like systematic Prisma guidelines or anything, but he was one of like his thought is something which is translated into devising these kind of things which you could do systematically, right? So this is like this is what he has done, and special thanks to my supervisor, master thesis supervisors, Sir Jayaprakash Tripathi and Arun sir, for guiding me throughout the process. Thank you all. Thank you for listening.
Thank you, Yogesh. It is really great to know all these things. And so what we will do is we will take a break. Merry Christmas to all of you. Today is December 25th. So there is something Dr. Tripathi has done for us, and we'll go out and see what he has done. And we'll come back, and we have also a very renowned professor that Dr. Chris who will be joining us on talking about statistical modeling for disease aspects. And so it will be very relevant topic. We'll come back and hear what she has to say. But let's take a quick 10-15 minutes back, maybe 10 minutes. If there is a bigger celebration, then maybe 15 minutes. But I'm guessing 10 minutes will be okay. So we'll keep a tab on the time. Thank you.